चलिए क्लास 9th का चैप्टर 4 स्टार्ट कर रहे हैं। चैप्टर 4 स्ट्रक्चर ऑफ द एटम। In chapter 3 we learn how that atoms and molecules are the fundamental building blocks of matter. The existence of different kinds of matter is due to different atoms constituting them. Now the questions arise: what makes the atom of one element different from the atom of another element? And are atoms really indivisible? And proposed by Dalton. Atoms are really indivisible. Proposed by Dalton. We are their smaller constituents inside the atom. We shall find out the answer to these questions in this chapter. We will learn about subatomic particles and the various models that have been proposed to explain how these particles are arranged within the atom. A major challenge before the scientists at the end of the 19th century was to reveal the structure of the atom as well as to explain its important properties. The evaluation of the structure of the atom is based on the series of experiments. One of the first indications that atoms are not indivisible come from studying state electricity and the condition under which electricity is conducted by different substances. Charged particles in matter. For understanding the nature of charged particles in matter, let us carry out the following activities. Comb dry hair. Does the comb then extract a small piece of paper? Rub a glass rod with silk cloth and bring a rod near the inflammable. From these activities, we can conduction of rubbing from one another to become electrically charged. Where does the charge come from? A question can be answered when the atom individual and consists of the charged particles. Many scientists contributed in revealing the presence of charged particles in an atom. It was known at 19 they was not a simple individual particles but contained at least of subatomic particles. Subatomic particles electron are defined by J. J. Thomson. Even was the identified Goldstein that also discovered the presence of new radiation in the gas discharge, which is called the canal rays. These rays are positively charged radiation, which ultimately led to the discovery of the another subatomic particles. Subatomic particles had a charge equal to magnitude but opposite in sign to that of the electron. Its mass was approximately 2 times as the electrons. It was given name the protons. General electron present in the E proton is a P and a sub of proton taken unit of charge plus 1. The mass of electron is considered to the negligible and its charge are minus 1. It seems highly likely that the atom was composed of protons, electrons, multiple valence in the charge of the peripheral. The protons were the interior of the atom, for whereas the electron could easily be placed of the unknown proton. Now the big question was what sort of structure did these particles of the atom form? We will find the answer of the question below. The structure of an atom. We have learned Dalton's atomic theory in chapter 3, which suggests that the atom was indivisible and indestructible, but the discovery of two fundamental particles, electron and proton inside the atom led to the failure of the aspects of Dalton's atomic theory. He was considered the necessary to known how electrons and protons arrange with the atom. For example, many scientists proposed various atomic models. J. J. Thomson was the first one of the proposed model of structure of atom. J. J. Thomson first atomic model दिया था. Thomson's model of an atom. Thomson proposed the model of an atom to be similar to that of the Christmas pudding, and watermelon pudding. The electrons in the sphere of positively charged, were like currants, dry fruits in the spherical Christmas pudding. We can also think of a watermelon. The positive charge in the atom is spread all over like the red eligible part of the watermelon, while the electrons are sudden in the positively charged sphere like the seed of the watermelon. Positively sphere electronic sphere. Thomson model of atom. J. J. Thomson 1886-1940, a British physicist, was born in Cheetham Hill, a suburb of Manchester, on the 18 December 1856. He was awarded the Nobel Prize in Physics in 1906 for his work on the discovery of electron. He directed the Cavendish Laboratory at Bridge of 35 years of the senior research assistant, subsequently won Nobel Prize. Thomson proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charge are the equal in magnitude, so the atom was whole in electricity neutral. Although Thomson's model explained that atoms are electrically neutral, the results of experiments carried out by other scientists could not be explained by this model. He will be seen below. Rutherford's model of an atom. Ernst Rutherford was interested in knowing how two electrons are arranged with an atom. Rutherford designed an experiment for this. In the experiment, first moving alpha particles made of the fall on the thin gold foil. He selected gold foil because he wanted a thin layer of possible. The gold foil is about atoms thick. Alpha particles are doubly charged helium ions. Since have the atom of 4 units, the fast moving alpha particles have a considerable amount of energy. He was expected that alpha particles would be deflected by the subatomic particles in the gold atom. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. But the alpha particles scattering experiment have totally unexpected results. The following observations were made. Most of the fast moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, one out of every borohydra particles appeared to the doctor. In the words Rutherford, this result was almost the incredible. He was 5-inch shell of the piece of the tissue paper and come back and its Rutherford 1871 से 1837 he was born at Spring Grove on 30 August 1871. He was known as the father of nuclear physics. Father of nuclear physics. Rutherford, father of nuclear physics. Famous. He is famous on his work on the radioactivity and the discovery of the nucleus of the atom with the gold foil experiment. Nucleus का खोज किया था रदरफोर्ड and the gold foil experiments is the Nobel Prize of the Chemistry 1800 1909 1908 में नोबेल प्राइज दिया था 1908 में नोबेल he checked the activity of open and understand the electrical and his experiment. Let a child stand on the front of a wall, thin eyes closed, and follow a stone and for the distance. He will hear a sound when each stone strikes the wall. He repeated it 10 times. We will the sound when time 10 times. But if the foil and the two throw stones at Provided for most of the stones with the not hit pressing and no sound should be heard. However, the last of gaps of the foil stone will be gaped through the following similar reasons. Rutherford concluded for the particle scattering experiment. Most of the space inside the atom's empty because most of the alpha particles pass through the gold foils with getting deflects. Very few particles very deflected from the path indicating that the positive charge of the atom occupied very small space. A very small fraction of alpha particles were deflected by 180 indicating to the positively charged mass of the gold atom. They are concentrated in the small volume with the atom. From the data he has also calculated the radius. The nucleus is about 10 to the power 5 times than the radius of the atom. From the atom, on the basis of the experiment, Rutherford put forward the nuclear model of atom, which had the following features. There is positively charged center of an atom called the nucleus. Positive मतलब एटम के बीच में पॉजिटिवली चार्ज होता है जिसको न्यूक्लियस कहा जाता है. न्यूक्लियर the small atom inside the nucleus. The electron revolve around the nucleus in well-defined orbit. The size of the nucleus is very small compared to the size of the atom. एटम के साइज से भी ज़्यादा छोटा होता है न्यूक्लियस. Drawback of Rutherford models of atom. The orbit revolution of the electron is expected to be stable. Any particles in the circular orbit would undergo acceleration during acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy. With the final failure of the nucleus. This were so. Atoms would be highly unstable. Hence, the would be exist from the none of the atom quite stable. Bohr's model of atom. In order to overcome the objections raised against Rutherford model of the atom, Niels Bohr put forward the Niels Bohr flowing postulated about the model of an atom. Only certain special orbits known as discrete orbit of electron are allowed inside the atom, while resolving in discrete orbit in the electron do not radiate energy. Electron do not radiate energy. Resolve the orbit. नील बोर्स 1855 से 1862 was born on 7 October 1885. He was appointed professor of physics at Copenhagen University 1916. He got Nobel Prize for the work on the structure of atom in 1922. Among Professor Bohr's numerous written theory appears books: The Theory of Spectra and Atomic Constitution and Atomic Theory, the Atomic Theory, and दूसरा था The Description of Nature. 3 बुक उन्होंने लिखा था: Theory of Spectra and Atomic Constitution and Atomic Theory and the Description of Nature. These orbits or cell are called energy level. Energy level in the atom are shown इतना. Ncert 4 3 2 1. A few energy level of the atom. These orbits or cells are represented by the letter K, L, M, N or the number of 1, 2, 3, 4. Nucleus. Neutrons in 1832 James Chadwick discovered another subatomic particles which had no charge. Here are the mass nearly equal to that of a proton. It was eventually named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen. है ना? हाइड्रोजन को छोड़कर सारे एलिमेंट में क्या होता है? न्यूट्रॉन होता है. न्यूट्रॉन होता है न्यूट्रॉन होता है. हाइड्रोजन छोड़ के सारे एलिमेंट में क्या होता है? न्यूट्रॉन होता है. इन जनरल ए न्यूट्रॉन इज प्रेजेंटेड एज एन. द mass of an atom is therefore given the atom of the mass of the proton and neutron present in the nucleus. Proton and neutron present in the nucleus. Nucleus में क्या होता है? प्रोटॉन और न्यूट्रॉन प्रेजेंट होता है न्यूक्लियस में, लेकिन हाइड्रोजन में नहीं होता है. हाइड्रोजन में न्यूट्रॉन नहीं होता है. हाइड्रोजन ही एक ऐसा है जिसमें न्यूट्रॉन नहीं होता है. सारे एलिमेंट में न्यूट्रॉन होता है. How the electron is distributed in the different orbits and cells. The distribution of electron into different orbits of an atom was suggested by the Bohr and Body. It follows rule Bohr and Body. Rule the following written number of electrons different energy level. The maximum number of electrons present in the cell is given by the formula of 2n square. 2n square का फार्मूला कौन दिया था? बोर बॉडी स्कीम दिया था. He were in orbits of the number of energy level index 1, 2, 3. Hence the maximum number of electrons or different cells are as follows. First number of K cell will be 2n square. 2 into n square. n 1 है 1 square और 2. Second orbit 2 into 2 का स्क्वायर 4 4 में 8. दूसरे में 8. एल सेल में 8 इलेक्ट्रॉन ज़्यादा से ज़्यादा रह सकता है. ए सेल में 2 इलेक्ट्रॉन. एल सेल में 8 इलेक्ट्रॉन. 2 into 3 18. एम सेल में 18 इलेक्ट्रॉन एंड देन एन सेल में 32 इलेक्ट्रॉन. उससे कम हो सकता है, उससे ज़्यादा नहीं हो सकता. द मैक्सिमम नंबर ऑफ इलेक्ट्रॉन्स that can be accommodated in the outermost cell of outermost orbit in the cell. Electrons are not accommodated in a given cell unless the inner cell Inner cell or field, that is the cell or field of the stepwise manner. Atomic structure of the first 18th element is shown schematically. बोर बोरी स्कीम दिया था 2n² का स्कीम दिया था, जिसमें हाईएस्ट कितना मतलब इलेक्ट्रॉन रह सकता है। तो के सेल में 2 इलेक्ट्रॉन ज़्यादा से ज़्यादा रह सकता है हाईएस्ट। एल सेल में 8 इलेक्ट्रॉन और एम सेल में 18 इलेक्ट्रॉन, एन सेल में 32 इलेक्ट्रॉन। कौन दिया था? बोर बोरी दिया था इसका नियम। 2n²। वैलेंसी, we have learnt how the electron in an atom are arranged in different cells orbits. The electron present in the outermost shell of the atom are known as the valence electron. The Bohr-Bury scheme was also known as the outermost shell of the atom. Atom can accommodate a maximum 8 electrons. We observed that the atom element have the completely filled outermost shell, little chemical activity. The other one, combination capacity of the zero inert element. Helium atom has 2 elements as the outermost shell, and all other elements have atom with 8 electrons outermost shell. The combining capacity of the atom, the other element, that is tendency to the react on the other molecules with the atom of the same different element, was thus explained as an attempt to attain a full outermost shell. An outermost shell which had 8 electrons was said to possess an octet. Atoms which thus react so as the achieve of the octet in the outermost shell. This was done by the sharing, gaining and losing electrons. The number of electrons gained, lost or shared, so the mass of octet electrons in the outermost shell, give us directly the combining capacity of the element, that is the valency discussed in the previous chapter. For example, hydrogen, lithium, sodium, and the carbon electron is their outermost shell. Therefore, each one of them lose 1 electron. So they say to valency of the 1. We can tell what is the valency of magnesium and aluminum, what is the 2 and 3 respectively. Because the magnesium has 2 electrons in the outermost shell, aluminum has the electron in the outermost shell. If the number of electrons in the outermost shell and an atom is close to its full capacity, then valency is determined in the different ways. For example, the fluorine atom has 7 electrons in the outermost shell, and fluorine का कितना है? outermost 7 electrons in the outermost shell, and valency should be 7, but it is eraser of fluorine to gain 1 electron instead of losing 7 electrons. Hence, its valency is determined the subtraction 7 electrons from the octet, and given you have valency of the 1 or for fluorine. Valency can be calculated in the similar manner for oxygen. What is the valency of oxygen? What is the from calculation? Therefore, an atom is the element has the definite combination capacity called its valency. Valency of the first 18th element is given in the last column. Atomic number and the mass number. Atomic number, we know that protons are present in the nucleus atoms. In the number of protons, atoms determine its number of determinant Z, or the atomic number of the Z. Element defines the number of protons possessed. For hydrogen for Z1, because the hydrogen atom only one proton present in the nucleus. Nucleus में प्रोटॉन होता है, हाइड्रोजन के न्यूक्लियस में क्या होता है, ओनली प्रोटॉन होता है और कुछ नहीं होता। हाइड्रोजन के न्यूक्लियस में क्या होता है, बस एक प्रोटॉन होता है। Similarly, for carbon Z, therefore the atomic number of and total number of protons present in the nucleus of the atom. Moles number. After studying the properties of the subatomic particles of an atom, we can conclude that mass of the atom is practically due to protons and neutrons. Practically due to protons and neutrons alone. These are present in the nucleus atom. Hence, protons and neutrons are also called nucleons. For mass of an atom is nucleus. For example, mass of carbon 12 because of the 6 proton and the 6 neutrons. 6 plus 12. Similarly, the mass of aluminum 27 13 proton and 14 neutrons. The mass of the defined of the sum of the total of the protons and neutrons present in the nucleus. Proton and neutron and the nucleus and the atom. In the notation of the atom, the number of mass and the inter of the element are 10. Mass number, number of element, atomic number. और इसमें नाइट्रोजन इतना, नाइट्रोजन का एटॉमिक मास 14 और एटॉमिक नंबर 7. Isotopes. In nature, a number of atoms of some elements have been identified with have the same atomic number but different mass number. क्या है, एटॉमिक नंबर इसमें सेम है, सेम एटॉमिक नंबर, सेम एटॉमिक नंबर। Same atomic number but different mass number, different mass number, different mass number, different mass number, different mass number. For example, hydrogen atom has 3 atomic species. Hydrogen atoms 3 atomic species: protium, deuterium and tritium. Protium H एक मास नंबर कितना 1 और एटॉमिक नंबर 1 तो प्रोटियम। ड्यूटेरियम मास नंबर 2 और एटॉमिक नंबर 1 ड्यूटेरियम। एंड ट्रिटियम मास नंबर 3 और एटॉमिक नंबर 1। एटॉमिक नंबर सबका सेम है और मास नंबर डिफरेंट है, डिफरेंट मास नंबर यहाँ डिफरेंट मास नंबर 1 2 3, ट्रिटियम का 3 मास नंबर। एटॉमिक नंबर सेम एटॉमिक नंबर, उसको आइसोटोप कहता है। Atomic number of each one is 1. The mass number is 1 respectively of the other atoms. और कार्बन का एटॉमिक नंबर 6 एंड मास नंबर 12 है। फिर कार्बन का 6 और 14, क्लोरीन का 35 और 17 और 37। ये एग्जाम्पल आइसोटोप्स हैं। क्लोरीन का आइसोटोप, कार्बन का आइसोटोप, हाइड्रोजन का आइसोटोप। On the basis of these examples, isotopes are defined as the atom of the same element having same atomic number but different mass number. Therefore, there are 3 isotopes: the hydrogen atom, namely protium, deuterium और tritium. हाइड्रोजन का 3 एटॉमिक आइसोटोप्स होता है, प्रोटियम, ड्यूटेरियम, ट्रिटियम। How many elements consist of a mixture of isotopes? Each isotopes of an element in a pure substance. The chemical properties of isotopes are similar but their physical properties are different. chlorine occurs in nature of two isotopes. Chlorine is a question of two atoms of synthesis and the ratio of the 3 ratio 1. Obviously, question of what is the mass chlorine atom found. The mass of an atom is neutral element. It is the average mass of the all neutral opening atom of the element. If an element has no isotopes, then the mass of atom would be the same or the sum of the protons and neutrons. But if an element occurs in isotopes forms, then we have to know the percentage of each isotopes form and then average mass of the calculated the atom mass number of chlorine atoms. The basic above data. This does not mean that any one atom of chlorine had fractional mass of the atom. It means we have the quantum of the atom chlorine in the both are two sorts, chlorine and the average of the properties. Application science and chemical properties of all the isotopes of an element are the same. Normally we are not concerned about the mixture of the some isotopes have special properties which are often useful various types and isotopes uranium in the fuel of nuclear reactor. Uranium nuclear reactor में होता है. Isotope of the cobalt used the treatment of cancer. Cobalt isotop इसमें इस्तेमाल किया जाता है कैंसर में. आइसोटोप ऑफ द आयोडीन यूज्ड द ट्रीटमेंट ऑफ गुआटर में आयोडीन का इस्तेमाल करते हैं. इसका केमिकल प्रॉपर्टीज भी सेम होगा. केमिकल प्रॉपर्टीज सेम, फिजिकल प्रॉपर्टी डिफरेंट है. आइसोबार्स consider two elements calcium atomic number of 20 and argon atomic number of 18. The number of electrons these are the different of the mass number of the both elements of 14. There are two total number of neutrons and the same of the atoms are pair of electrons. Atoms of the different elements with the different atomic mass with the same mass number और डिफरेंट क्या एटॉमिक नंबर डिफरेंट एटम्स एटॉमिक नंबर डिफरेंट मास नंबर सेम. इसे आवश्यक बार कहता है. बस इतना ही है. क्रेडिट एंड डिस्कवरी ऑफ इलेक्ट्रॉन प्रोटॉन वाज जे थॉमसन एंड गोल्डस्टीन. प्रोटॉन को फिर गोल्डस्टीन किया तो इलेक्ट्रॉन का जे थॉमसन प्रपोज द इलेक्ट्रॉन एंड एम्बेडेड इन द पॉजिटिव स्फीयर. Rutherford alpha particles scattering experiment led to discovery of atomic nucleus. Rutherford model of atom proposed the very nucleus present inside the atom. Electron dissolved in the nucleus. Stability and the atom explain this model. Neil Bohr's model of atom successfully moved electrons are distributed in the cells where the created energy and the nucleus. Atom cells are complete. The will is stable to less reactive. James Chadwick discovered the presence of neutrons in the nucleus. So in the atom there are subatomic particles of the atom: electron, proton, and a neutron. Electron is the negatively charged, proton is the positively charged, and a neutron have no charge. The mass of electron is about ethna times the mass of hydrogen of atoms. Proton take unit. Shell of the atom is designed with KLMN. Valency of the combined capacity of the atom. Atomic number of the electron is the same the number of protons and in the number of nucleus in the atom. The mass number of an atom is equal to the number of neutrons in the nucleus. Isotopes are atoms of the same element which have different mass number. Isobars having same mass number but different atomic number. Elements are defined by the number of protons they possess. रदरफोर्ड अल्फा पार्टिकल्स से एक्सपेरिमेंट करता है। न्यूक्लियस डिस्कवर्ड बाय न्यूट्रॉन, न्यूक्लियस का खोज किया था इलेक्ट्रॉन, न्यूट्रॉन करता है। इलेक्ट्रॉन को खोज जे थॉमसन, प्रोटॉन को खोज गोल्डस्टीन करते। आइसोबार में एटॉमिक मास सेम, एटॉमिक नंबर डिफरेंट। एटॉमिक मास सेम, एटॉमिक नंबर डिफरेंट। और आइसोटोप में एटॉमिक नंबर सेम, डिफरेंट मास नंबर डिफरेंट। हाइड्रोजन का आइसोटोप्स प्रोटियम, ड्यूटेरियम, ट्रिटियम। प्रोटियम, ड्यूटेरियम, ट्रिटियम। उसके बाद यूरेनियम आइसोटोप न्यूक्लियर रिएक्टर में काम करते हैं। कोबाल्ट को कैंसर में इस्तेमाल करते हैं और आयोडीन को गोइटर में इस्तेमाल करते हैं। हाइड्रोजन, हीलियम, लिथियम, बेरिलियम, बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन, फ्लोरीन, नियन ये हाईली रिएक्टिव होता है। इलेक्ट्रोनेगेटिविटी में सबसे ज़्यादा रिएक्टिव है। सोडियम, मैग्नीशियम, एल्युमिनियम, सिलिकॉन, फास्फोरस, सल्फर, क्लोरीन, आर्गन। हाइड्रोजन के पास क्या नहीं होता है? न्यूट्रॉन नहीं होता है, प्रोटॉन होता है सिर्फ इसके पास। न्यूट्रॉन होता है, प्रोटॉन इलेक्ट्रॉन नहीं होता है। न्यूक्लियस सबके पास होता है, लेकिन हाइड्रोजन के पास न्यूक्लियस नहीं होता। नील बोर्स पर 1855 1865 नील बोर्स एटम। रदरफोर्ड गोल्ड फॉइल एक्सपेरिमेंट। रदरफोर्ड ही किया था, नोबेल प्राइज 1908 में मिला था। न्यूक्लियस की खोज किया था, गोल्ड फॉइल लिया था। उसके बाद क्या लिया था? अल्फा पार्टिकल को पास कराया था गोल्ड फॉइल से। और अल्फा पार्टिकल से पॉजिटिवली चार्ज है। अल्फा पार्टिकल क्या है? पॉजिटिवली चार्ज है। और पॉजिटिवली जब टकराता है तो वो रिपेल करता है। तो उसी से पता लगा कि इलेक्ट्रॉन में क्या है, एटम में क्या है, ये चार्ज पार्टिकल है। लार्ज डिफ्लेक्शन हुआ था। पार्टिकल एटम अच्छा है। इलेक्ट्रिक न्यूट्रल, पॉजिटिवली चार्ज, नेगेटिवली चार्ज। थॉमसन मॉडल स्फीयर लिया था, पॉजिटिवली स्फीयर, और उसमें कहा कि इलेक्ट्रॉन मतलब उसमें भरा सा रहता है, भरा सा रहता है। चीज़ को प्लम पुडिंग मॉडल कहता है, वाटरमेलन मॉडल कहता है, क्रिसमस पुडिंग मॉडल भी कहता है। जे थॉमसन सबसे पहले एटॉमिक मॉडल कौन दिया था? डाल्टन दिया था। एटॉमिक थ्योरी दिया था डाल्टन, और एटॉमिक मॉडल दिया था जे थॉमसन। फर्स्ट एटॉमिक मॉडल दिया था जे थॉमसन, और एटॉमिक थ्योरी दिया था डाल्टन। चलिए, तो आज का चैप्टर मेरा ख़त्म। नेक्स्ट चैप्टर फिर पढ़ता हूँ। इतना ही आज का इसमें। नेक्स्ट चैप्टर क्या है? सेल, फंडामेंटल यूनिट ऑफ लाइफ। ठीक, सेल पढ़ते हैं दूसरे दिन। प्रश्न